Hi, it's Nigel here from MedSeller. We're going to be doing some testing today. We're going to test some tourniquets out of the Rhino Rescue Bleeding Control Kit. I have a box of 8 that were taken from kits that we've broken down into their constituent parts, and I'm going to have a rummage around and I'm going to pick that one at random. Okay, so here we are just proving the test harness. We've got a previous generation Rhino tourniquet here, metal windlass, and we've got this contraption with weight scales, as in packing scales, in here, and we've controlled it as best we can. The weight settles a little bit after the thing's been loaded up, as things stretch and the wood gives and what have you. But you can see here that we're loaded up to about 130 kilograms. This is just our proof of concept and our benchmark. Just to show you how tight this is, we're struggling to get it off. There we are. Okay, so next up we've got the Dnipro tourniquet. We're starting with hopefully 0 on the scales. There we are. It's the total load that we're interested in, so it doesn't really matter where we start from. And I'm going to have to come around there to wind this up because it's going to be blooming tight. So here we go. Again, because we're interested in total load, the number of turns is a bit irrelevant really, because it would depend anyway on how tight you start from. The interesting thing about this is it is turning more easily than the Rhino counterpart. So it's taking more turns in order to achieve a similar sort of load. So here we are, that's the next nearest turn. We're at 140, and as we said earlier, as the test harness compresses, that will back off. Okay, next up we've got the C-A-T Gen 7. Here we are, we've got 0 on the scale, so there's no pressure on the tourniquet yet. We're belted up. Let's see what we can do with this one. Okay, this is curious because here the plastic buckle that supports the windlass is deforming. It's not holding the windlass in place. So let's try and get that in. Can we see? That's deforming. So whilst the product is not going to break, that's not working. We're not able to get the same load on it. We might be able to hold it with that Velcro, but that's a bit hit and miss. That's not such a good outcome, I don't think. Okay, so next up we've got the Rhino Rescue tourniquet. Still in its wrapper, the one that we selected at random earlier. Let's see if we can get this one up around the 130. can actually see the improved design on this one. It just seems to be a little bit easier to get the windlass into the cup, and blimey, we seem to be at 157 kg. Okay, so we've given it about 10 minutes, and whilst we've had a chat and figured things out, and after that time the test harness has relaxed a little bit, the wood's settled a bit, and she's settling at around about 136. She's not moving very fast now, so that's still above the other tests that we've done so far. So to wrap up then, we started off with our benchmark. This is the previous version of the Rhino metal tourniquet. That seemed to fare well as our benchmark. We had the Dnipro tourniquet. That was absolutely fine, no bother at all. We had the C-A-T Gen 7. That didn't fare quite so well as the others. It didn't achieve the same pressure before the cup into which you place the windlass when the pressure's on the tourniquet. That was starting to deform and didn't hold the windlass sufficiently well. And we had the Gen 2 Rhino metal tourniquet, and that was as good as all of them. So no problems whatsoever, and definitely an improvement on the first generation.